Moving on to 15.6, we have polymorphism and virtual member functions. Let's just tackle the first thing first. Why or what or how is polymorphism? Perhaps even when is polymorphism? Um, the idea here is that if we have a a, a base class and a member class, if we have a general and a specific class, we have something that can be more than one thing at a time. So let's look at just a different kind of an example from here at Rock Valley College, and I hope that by deviating from what we have here at the text, it makes a little bit more sense. We have teachers as a class of objects, and I think that students make sense as a different class of objects. Now, students and teachers are probably largely the same, right? We would all have first names, last names. We would have an identification number. So you would have an S number, I would have an E number. We would have addresses, zip codes, all of those things. And those would be things that are common between our two otherwise used very, very differently classes. Now, as far as programming goes, it makes sense that we would have an abstract class. We would call it something. Now, again, this goes back to 3 videos ago where I said one of the things that you will find is to define the abstract class is often difficult because it's not something that you can point to. So could we call it an RVC member? Sure, because you as a student are a member of RVC. I, as a faculty, am a member of RVC. And honestly, I didn't think of it before I started talking into the camera. So RVC member it is. So RVC member would be the base class from which both student and teacher or faculty are derived. Now, the idea of polymorphism is that any object can be derived of multiple different classes. Polymorphism, made of more than one. So even if I point at you as a student, so you are an instance of the student class. You are also, however, a RVC member. So that's the idea of the polymorph. You are one thing that is comprised of many, and you are, in fact, at the same time, multiple different classes. So the difficulty here comes with the idea of the redefined function. Let's say, for example, that we have a function, so a method that is part of the RVC member class. Now, in the faculty class, we would also have a redefined method. So with the same name, potentially with the same parameters, but it would have some sort of a different output. Now, the student would also have a redefined function that's the same name as one that is found in the RVC member class. Sometimes you get into an issue with polymorphism when you call to a function that is or it has the same name rather in the base class as it does in the derived class. Now, what ends up happening is the idea again of binding. It's whether or not the object that we're referring to was available at the time of compiling, or if that object became available later on through runtime. If something is statically bound, it has to be declared and used the way it is at compile time. In dynamically bound, it is something that can be bound by C++ during the actual runtime, which is really very, very different. So if we track down here from 948, we have this example of the pass-fail activity here, and this is on page 951. And the set function here is redefined in our derived class, but because of the static binding, the function that C++ calls is actually from the base class, and we don't want that. The easy way to get around this is to declare a members function as virtual, and it is literally just that. In the derived class, we would add the virtual keyword like you see here on line 26. I probably have to move this over. It would be right over here. Virtual char get letter grade constant. On line 26 here, what we're doing is in the pass-fail activity class, which remember, graded activity, pass-fail activity, and then pass-fail exam. That's the chain of inheritance that we have here. So rather than relying on static binding, which says that when we are making a call to, in this case, it would be an assignment. Rather than making a call to its base class, we want to make a call to the derived class's member function. And the only place we have to note this is here in this case, it is pass-fail activity.h, but it's in the header file. We do not have to, in main, for example, we do not have to indicate that it is a virtual member function. That is taken care of by declaring it so here in the header. So that simple keyword, virtual, is an indication to C++ that this is dynamically bound instead of binded. It is dynamically bound during runtime as opposed to at compile time, which is sometimes disadvantageous. The reason this becomes disadvantageous, and again, this is actually on page, it is 948 and 949 here in the text, is when we are using objects, we are either passing them by reference or we are passing them by a pointer. And because we are passing them by a pointer or by a reference, remember that we are not creating copies of those objects. So what ends up happening is we have the original reference to our base class, and that is why the call to the derived class's function doesn't work. Now, that's something that should sound awfully familiar here in C++277 is, we've been working an awful lot with the idea of pointers and addresses as opposed to passing by value. So really here, the simple inclusion, and I believe we still have it right here on line 26, virtual, is the way we can assure that we are dynamically binding and thereby referring to the derived class. Now, one of the things I know has come across in the language here in chapter 15 is the increase in, can I call it the complexity of the jargon, the static versus dynamic binding at the time of compile versus at the time of run when we're looking at a derived or a base class's constructor. All of these things are jargon, definitions upon definitions upon definitions. And that really is the next big implementation, not that you'll see here in class necessarily, but it's the next big step that you need to take as a developer when we release you out into, the great wide world of developers working with developers on a development, hence the word developer. You need to be able to communicate in a way that is highly specific and highly shorthanded so that you can get a lot of work done and a lot of meaning behind that collaboration in a very, very short order of time. And that is what all of this vocabulary here is aiming to help you do, is get the jargon right so that when you are expressing these ideas to the next developer in the chain, you can take a mountain of information that we need to express and condense that down into a very, very short verbal exchange, or a very, very short written exchange if you're doing it over Slack or Teams or email or carrier pigeon. And that way, you have conveyed all the meaning you need to convey, but you have shortened it so that we can have one expert to another communicate that idea. So I know that there has been, we are here in 15.6, so the previous 6 portions of this chapter, and it doesn't get any better in the last 2 portions of this chapter, but hearing and using and expressing with all of these nomenclatures that you hear here is the key to successful communication with other developers in the chain. Also, polymorphism, one from many.